Hi everybody, in this video, let's look at system of linear inequality in two variables. In this part, you will be given a situation and several conditions will be given to you. From that, you have to form a few linear inequality. Okay, let's look at example number 7. A private university accepts students for computer science and accounting courses. So we have two courses here. Let me write down the two courses first. Computer science, and then we have accounting. Okay, so given the private university accept X student, so the number of students for computer science can be represented by X, and the number of students for the accounting course can be represented by Y. Okay, let's go back to this beginning part. It's given that the total number of students for these two courses cannot exceed 700. The total number of students means that the sum of X and Y, right? So X plus Y cannot exceed. It means less than or equal to 700. So now we have formed the first inequality. The number of students taking accounting course, this cannot be more than, it means less than or equal to twice the number of students taking the computer science course, twice of this. So you have to take 2 times X. Okay, so each computer science and accounting student has to pay a yearly tuition fees of 4,800. So this is 4,800, and this is 4,000. The total amount of the tuition fee received in the year from the two courses is at least 2,400,000, correct? Yes. Okay. Given the private university accept X student, okay, this one no problem. Now, one student for the computer science, you need to pay 4,800. Two students, you have to take this one times 2. Now you have X student, so you take this times this. So it will be 4,800X plus 4,000 Y, at least greater than or equal to 2,400,000. Okay, so this inequality looks pretty big, right? The number, you can actually reduce it. Okay, first I just divide the whole inequality by 100. So it becomes 48X plus 40Y is greater than or equal to 2,400,000. Okay, so I still can reduce further. How about I divide the whole inequality by 8? 6X plus 5Y is greater than or equal to 3,000. Okay, so this is the second inequality, and this is the third inequality. Okay, so this is a way how we form a few inequality from a given situation. Okay, let's proceed to the next example. Based on the diagram, based on the below diagram, determine the regions that satisfy each of the following system of linear inequality. So okay, let's look at A first. Let me copy A first. 2x plus 3y is greater than 3. Then I have another inequality, y is greater than x minus 2. Okay, I hope that you still remember in the previous video I told you that when you want to determine the regions that satisfy linear inequality, two things. Make sure you look at y and make sure the coefficients of y is positive. Okay, now this coefficient of y is positive, so it will be easier. So when we want to determine this region, I have to look at this line. 2x plus 3y is equal to 3. I have to look at this line. Okay, you will notice that all the symbol here is greater than or less than. That's why the two lines drawn here are using dotted line or dashed line. Okay, 2x plus 3y is equal to 3. This will be the line. Greater than is on the top here. Okay, we just make some marking here first. Y is greater than x minus 2. So we have to look at this line. Y is equal to x minus 2. Y is equal to x minus 2 will be this straight line. It's greater than on the top here. Above this straight line. Okay, so from here I know that the regions that satisfy this both inequality will be here, right? This is a region that satisfies the two linear inequality. So the answer is region A. Okay, so let's proceed to B. Okay, so B is 2x plus 3y is greater than 3, y is less than x minus 2. Okay, same thing, 2x plus 3y is greater than 3. We just look at 2x plus 3y is equal to 3. So greater than will be here, above this straight line. Okay, so now for this inequality, I have a look at y is equal to x minus 2, less than, below this straight line. So from here, you will notice that this is a region that satisfies both linear inequality, correct? This is a region that we want. So the answer is region C. Okay, let's go to part C. Two x plus 3y is less than 3, and then we have another inequality, y is less than x minus 2. Okay, let me erase this one first. Two x plus 3y is less than 3. It means below this straight line. Make some marking first. And y is less than x minus 2. Y is equal to x minus 2, less than, same thing below here. So from here, we will notice that the regions that satisfy these two linear inequality will be A, B, C, or D. D, right? Here. This is a region that we want. Okay, let's go to last one. Two x plus 3y is less than 3, and then I have another inequality, y is greater than x minus 2. 2x plus 3y is less than 3. Okay, so less than, below. Y is greater than x minus 2, greater than, above. So always remember, when you want to determine the regions above or below, make sure you look at y and make sure the coefficients of y is positive. Okay, so from here, the overlapping area, the common regions for this both linear inequality will be here, right? So the answer is regions B. So this is the way how we shape the region that need to satisfy a few linear inequality. Okay, let's look at this example. Determine whether each of the following point is the solutions of this system of linear inequality. So I have two inequality here. X plus y is greater than 2, and 2x minus y is greater than or equal to 3. So I want to test, is this point satisfy this both simultaneously? If yes, that means this is the solution for this system of linear inequality. Okay, let's test the first point, A. So now I have two parts, x plus y and 2. Okay, so x plus y will be equal to 4 plus 1. 4 plus 1. Okay, this is equal to 5. Now I compare these two. 5 is greater than 2, correct? So now what is 5? 5 is x plus y. I write this whole thing, replace the 5 here. Okay, satisfied, correct. So this point satisfies this inequality. How about this? Now let's test using the same point. So now I break this become two parts, 2x minus y, and then right hand side I have 3. At this point, 4, 1. So 2 times 4 minus 1. So this is 6 minus 1 is equal to 5. Oops, sorry, I make some mistake here. So this is 4, 2, 4 should be equal to 8. Okay. So this is 7. Okay, let me check again, correct or not. Okay, so now I just compare these two, 7 and 3. 7 is greater than 3. So what's 7? 7 is 2x minus y, right? So since this is using greater than or equal to, I can just follow the symbol. So 2x minus y is greater than or equal to 3. Okay, so this point satisfies this inequality as well. So this point is the solutions of this system of linear inequality. So how about the second point? Let's test the second point, 1, 2. Okay, same thing. I break it become two parts, x plus y and 2. So now I'm testing. I am using this point 1, 2. X is equal to 1, y is equal to 2. So this is equal to 3. 3 compared with 2. 3 is greater than 2. Okay, so 3 is x plus y. X plus y is greater than 2. Okay, so this point satisfies this inequality. So how about this one? 2x minus y, and then I have 3 here. So 2x minus y. So this is 2 minus 2, this is 0. Okay, compare this both. 0 is less than 3. So 0, you can say less than or equal to. So this is 2x minus y. 2x minus y is less than or equal to 3. Oh, so this point does not satisfy this inequality. So this point is not the solution of the system of linear inequality. So this is the way how we test. Okay, let's look at the next example. Write 3 linear inequalities such that the point A, now I have to focus on point A, such that point A is a solution of the system of linear inequality. So let's look at this line first. This line. Okay, 2x plus 3y equal to 6. And do notice that this point is located below this straight line, and the line is drawn using a solid line, right? Below, less than. And since that this is a solid line, it will be less than or equal to. Okay, so now let's focus on this line. Y equal to 2. Y equal to 2. And this point is located below this straight line. It means less than. We don't have to write, we cannot use this symbol because this is a dashed line. So we have to change this symbol to less than. Y is less than 2. Okay, let's go to the last inequality. Now let's focus on this straight line. Y is equal to x minus 3. And this point is above this straight line, right? Okay, and this straight line is a solid straight line, then it will be greater than or equal to. Okay, let's go to part B. Which of the following point A, B, C, D is a solution of the system linear inequality for this 3 linear inequality? Y less than 2, Y is less than 2. Okay, this is Y equal to 2, less than mean below. We make some marking here first. Below. Y is greater than or equal to x minus 3. X minus 3, right? Y is equal to x minus 3, greater than or equal to, above. And 2x plus 3y is greater than or equal to 6. So 2x plus 3y is equal to 6. Now this is greater than or equal to, so it will be above this straight line. From here, we will notice that the regions that satisfy both linear inequalities simultaneously will be here, right? Here. Okay, so this is the region that we want. So the answer is which point? Okay, which point, right? So it will be which point will be point C. Okay, so next, let's try this example. On the diagram, shade the regions that satisfy a system of linear inequality for this 3 linear inequality. So y is greater than or equal to 2x, y is less than 6 minus x, x is greater than or equal to 0. Okay, when you want to determine the region of an inequality, make sure 2 things. Hopefully you still remember. Make sure you look at y and y is positive. Okay, so y is greater than or equal to 2x. I have to look at this line. Y is equal to 2x, which is here. And it's greater than above this part. Above. Okay, now this y is less than 6 minus x. We have to look at this line. Y is equal to 6 minus x. So below, right? Less than, below. Okay, now this is x is greater than or equal to 0. We have a look at x is equal to 0. Where is x is equal to 0? X is equal to 0 is actually here. The y-axis. Okay, it's greater than or equal to 0. So it will be here. Okay, so where is the regions that satisfy these 3 linear inequality simultaneously? Here will be the reason, right? This part. Okay, let me use a highlighter. This part. correct? Okay, so this is a regions that satisfy this system of linear inequality. Okay, let's try one more example here. Now we are given a shaded regions and we need to determine the linear inequality. Okay, so it means that first we have to find the equation of that straight line. Always remember, to find the equation of a straight line, two things, one point and the gradient. Okay, let's find the equation for AB first. AB. So now I want to find the gradient, right? Gradient. So gradient AB. I can use y2 minus y1 over x2 minus x1, or I can use another formula which is negative y-intercept divided by x-intercept. So now I know that the gradient is negative 1. Y equal to m x plus c. So now I need 1 point to find the c, but in this case I actually don't have to calculate because c is a y-intercept. From the diagram we know that the y-intercept is 3, and this negative 1 actually you don't have to write the 1. Y is equal to negative x plus 3. Okay, y is equal to negative x plus 3. But this is the equation of this straight line. The question is asking inequality. Okay, so I just find the equation for every straight line first. Later only I write the inequality. Okay, this one hopefully you understand. Now how about we proceed to find the equation of CD. Same thing, CD. Okay, this time I use another formula. Just now I used the formula negative y-intercept over x-intercept, right? Okay, now let's try using another formula, y2 minus y1 over x2 minus x1. So I have 2 points here, 1 point and 1 point here. On y-axis, x equals 0, and this is 3. On x-axis, y is equal to 0, and this is negative 3. So now I can use this coordinate to find the gradient of this straight line. y2 minus y1, 3 minus 0. If I take 3 minus 0, I have to do the same thing for the x part, 0 minus negative 3. I have to follow the sequence. So this is 3, this is 3 as well, then it will be 1. Okay, now again, y equal to m x plus c. And this one, you don't have to write, you just write x. C is a y-intercept. From this diagram, you know the y-intercept is 3, right? Okay, plus 3. This is the equation for this straight line will be y equal to x plus 3. Okay, we still have one last equation. Okay, this straight line. So this straight line is parallel to the x-axis, so it's very easy to determine the equation for this straight line. It will be y equal to 1, right? Okay, so now I have 3 equations. I have found all the equations of this 3 involved straight line. Okay, the next thing is to write the inequality. Okay, let's look at AB first. AB. You notice that the shaded region is actually below this straight line, right? Okay, y is equal to negative x plus 3. And this straight line is drawn using a dotted line. So I have to use less than. Why I use less than, not greater than? Because the shaded region is actually below this straight line. Less than. Okay, now we go to second straight line. Y is equal to x plus 3. Y is equal to x plus 3. y is equal to x plus 3. And the same thing, this shaded region is actually below this straight line. So I have to use a symbol of less than. But this straight line is a solid straight line, right? So I have to add this sign, less than or equal to. Okay, let's go to the last one, y equal to 1. The shaded region is above this straight line, and this straight line is a dashed line, dotted line. So I have to use this symbol, greater than. Okay, so this is the way how we find the inequality represented by the shaded region. Okay, so for this video, I just stop here first and see you in the next video. Thanks for watching. Bye bye.